Hey there, how's it going everybody? In the last video we learned how to create a simple class and how to create instances of that class. We learned a lot about instance variables, which are used for data that is unique to each instance. So instance variables are these here that are set using the self argument that we saw before. So for example, in the employee class that we created, we set the names, the email, and the pay in our initment. And those are set for each instance of the employee that we create. And I briefly mentioned class variables in the last video, but we didn't go into detail. And that's what we're going to learn about in this video. So class variables are variables that are shared among all instances of a class. So while instance variables can be unique for each instance, like our names and email and pay, class variables should be the same for each instance. So if we look here at our employee class, what kind of data would we want to be shared among all employees? Well, there's a lot of different ideas that we could probably come up with, but for this example, let's say that our company gives annual raises every year. Now, the amount can change from year to year, but whatever that amount is, it's going to be the same for all employees. So that would be a good candidate for a class variable. Now, before we actually create that class variable, let's first hard code this in and see why the class variables would be a better use case. So I'm going to create a method down here called apply raise. And remember, our methods automatically take in the instance, which we are going to call self. Now, within this apply raise, I'm going to do a self.pay, and I'm going to set this equal to an integer so that we have a whole number. And I'm going to do self.pay times 1 point, let's just make this 4%. So now if I was to test this down here on an instance, then I can print out the employee1.pay, and let me go ahead and copy this twice. And between here, I'm going to do an employee1.apply raise. Now, if I go ahead and run this, oh, and I actually forgot to put in the parentheses there. So now if I go ahead and run this, you can see that I printed out the pay, then we applied the raise, and it added 4% onto our pay. So we can see that it worked, but there are a couple of things wrong here. So first, it would be nice if we could access the raise amount by doing something like employee1.raise amount. Or since it would apply to the entire class, we should also be able to get the raise amount by doing employee.raise amount. Now that raise amount attribute doesn't currently exist, so we can't see that it is 4%. And also, what if I wanted to easily update that 4% amount? So right now, it's kind of hidden within this method. And for all I know, it could be in multiple places throughout our code. So we don't want to have to manually go in if we wanted to update this 4%. We wouldn't want to have to manually go in and change these in multiple locations. So let's instead pull this 4% out into a class variable. And that's as easy as going up here to the top of the class and just saying that we want a raise amount equal to 1 point, and we'll just do that at 4% still. So now instead of hard coding this 4% down here in our apply raise method, now let's go ahead and use this class variable. Now you might expect us to just be able to type in raise amount here, but if I save that, and I'm going to comment out these lines here. So if I save that and run it, you can see that I got a name error, and it says that raise amount is not defined. And that's because when we access these class variables, we need to either access them through the class itself or an instance of the class. So within the apply raise, I could either say employee.raise amount, and if I save that and run it, then you can see that that works. Or I can also access through the instance. So I can do self.raise amount, and if I run that, then you can see that that works as well. Now that might be a little confusing to you because if these are class variables, then why can we access them from our instance? So let me print out a few lines here to get a better idea of what's going on. So I'm going to go ahead and remove all of these lines here. Actually, I'm going to keep this. And I'm going to print out the employee1.raise amount. And I'm also going to print the employee.raise amount. And also, just to see all of our instances here, I'm going to also do the employee2.raise amount so that we can see all of them together. So now if I go ahead and print these out, you can see that I can access this class variable from both my class itself as well as from both instances. Now, what's going on here is that when we try to access an attribute on an instance, it will first check if the instance contains that attribute. And if it doesn't, then it will see if the class or any class that it inherits from contains that attribute. So when we access RaiseAmount from our instances here, they don't actually have that attribute themselves. They're accessing the class's RaiseAmount attribute. Now there's a little trick that we can do here to get a better idea of what's going on. So I'm going to go ahead and print out the namespace of employee1. And we can do that by printing out employee1 _dict. So now if I run this, if I were to access these names or email or pay, then these are the values that they would return. But you can see that there's no RaiseAmount here in this list. Now, if I printed out the employee dict and run that, now we're going to get a few things here that we don't necessarily care about. But if we look down here, then we can see that the class does contain this RaiseAmount attribute. And that is the value that our instances see when we access that RaiseAmount attribute from our instances. Now let me show you an important concept here. So I'm going to go ahead and comment this out. And I'm going to take this employee RaiseAmount and I'm going to set this equal to 1.05. And now I'm going to uncomment out our print statements here and rerun this code. And you can see that it changed the RaiseAmount for the class and all of the instances. Now, what if I was to set the RaiseAmount using an instance instead of using the class? So instead of doing employee.RaiseAmount equals 5%, I'm going to say employee1.RaiseAmount equals 5%. So if I run this now this might be a little unexpected. You can see that it only changed the RaiseAmount for employee1. It's the only one that has this 5%. So why did it do that? Well, when we made this assignment, it actually created the RaiseAmount attribute within employee1. So if I go back up here and print back out employee1's namespace, and I'm going to do this under the assignment. So now if I run that, now you can see that employee1 has RaiseAmount within its namespace equal to 5%. And it finds this within its own namespace and returns that value before going and searching the class. And we didn't set that RaiseAmount on employee2, so that still falls back to the class's value. Now that's an important concept to understand because up here in our apply raise method, we can see that we could get different results depending on whether we did the self, which is the instance RaiseAmount, or the employee class RaiseAmount. So in this case, I think I'm going to go ahead and leave this as self.RaiseAmount because that will give us the ability to change that amount for a single instance if we really wanted to. So if I wanted to change employee1's RaiseAmount, then I could go ahead and do that. And when I did apply raise, then it would use the employee1's RaiseAmount instead of the class's RaiseAmount. And also using self here will allow any subclass to override that constant if they wanted to. And we'll look at subclassing in a future video. So now let's look at another example of a class variable where it wouldn't really make sense to use self. So let's say that we wanted to keep track of how many employees that we have. So the number of employees should be the same for all instances of our class. So if I created a class variable up here, I'm just going to go ahead and call this num of employees is equal to 0 for now. And each time we create a new employee, I'm going to increment that by 1. And I can do that within the init method since the init method runs every time we create a new employee. So within here, I'm going to do employee dot number of employees plus equals 1. Now I'm definitely going to use employee.number of employees here instead of self.number of employees because with the raises, it's nice to have that constant class value that can be overridden per instance if we really need it to be. But in this case, there's no use case I can think of where we would want our total number of employees to be different for any one instance. So for now, I'm going to go down here to the bottom and go ahead and delete all of this. and I'm going to print out employee dot number of employees. So now if I go ahead and run that, you can see that it returned 2 because it was incremented twice when we instantiated both of our employees here. If I was to put this print statement above where we instantiated those employees, then you can see that it was 0 and we created 2 employees and then it printed out 2. Okay, so I think that is going to do it for this video. Now I know that that was a lot to take in, but hopefully now you better understand the difference between instance variables and class variables and when you would use each one. So one of the obvious next questions is, well, if we have class variables, then are there also class methods? And the answer is yes. There are these things called static methods and also class methods, and we'll look at the difference between those in the next video. But if you do have any questions about what we covered here, then feel free to ask in the comments section below and I'll do my best to answer those. If you enjoy these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up, and also it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, you can contribute through Patreon, and there's a link to that page in the description section below. Be sure to subscribe for future videos, and thank you all for watching.